as a next step, uh, we build a sequential model. We build a sequential model and add. We can add what? We can add convolutional layers and convolutional and max pooling layers. Convolutional and max pooling layers. And then to construct to design CNN. Okay, we're gonna do that. And then second, okay, we'll build a sequential model, and then yeah, CNN. And then what we are gonna do next is we also had to drop our layers somehow. We optionally we may add drop out layers, in between. So which is that randomly sub layers that randomly switch up some some neurons, some nodes in the network, some neurons or nodes in the network, neurons in the network. So which then so as to force the network to find what? If we switch off some neurons, they have to find new passes in the network, right? And then that to find new passes and to become more robust and robust. This avoid data mining, okay? This drove out reduces overfitting, therefore overfitting, right? And then at the end, we will add dense usual, then add the a usual dense network, to predict classes, which is 0 to 9. Classes 0 to 9. Okay, 0 to 9. So let's do that. So first, the model is sequential. So the model is sequential. We will build a sequential model. And then now we will add the very first one, model, add, and then we will add convolutional to the convolutional neural network. And then how many neurons? We will add 32 neurons, 2 to the power of 5 neurons. And then kernel size is, we will say kernel size is 3. I can just add 3, but for practice, I add 3 by 3 matrix. So 3 by 3 matrix. So, well, to show you, To remind you, the corner is like this one. Okay. So this corner value. So we will slide this 3 by 3 corner into the image to collect the information, right? So we will slide corner. Yeah. So yeah. Yeah, like this one. Slide corners like this one. Well, it is like a 3-dimensional, but in our case, it is just a 2D. So we can just move it 2D, one, slide through it. Yeah, so corner. Yeah, so 3 by 3 corners. Yeah, this one input image 3 by so input image and 3 by 3. I can slide this one over here. Then we have this feature map. So we will do that one. Okay. So corner size is 3 by 3, and then activation function, and then 3 by 3, and then this is getting longer, and then activation. As usual, relu function. Okay, and then input shape, input shape. What is the input shape? Input shape is, as you know, 28 by 28 by 1, right? This is input shape. Okay, so we added convolutional, the very first layer, with 32 maps. Okay, and then now we can add another one such that model add convolutional 2D, and then, well, we can add another one, and then corner size equals 3 by 3, and then activation function is now relu. We don't have to specify input shape because it's now hidden layer. Okay, and then maybe we can add another one, right? But because if I add too many one, then the model gets complicated and take a lot of time. So I'll make a model simple. Oh, by the way, after this convolutional network, I have to add max pooling to the and then here with the pool size is 2 by 2. What is the pool size? Max pooling. So CNN pool size CNN pool size is here. Yet we again, it is like similar to it is corner size, but as we slide through, in each pool we pick the maximum value here. Yeah, here the maximum value is here 9. So this goes to here, and then here we select maximum value is 7. 7 goes here, and then here maximum is here, and then here max is 6. So the max pooling. It is 2 by 2 because it is this one. Okay, this one. This is 2 by 2. For each 2 by 2 segment, we select the maximum value. So that's why it is 2 by 2 max pooling. Okay. Here this is 3 by 3 max pooling. Okay. Of course, we can use 3 by 3, but let's just use 2 by 2. Okay. Then let's go back. Okay. 2 by 2. And then, yeah, corner size is 3 by 3. Max pooling, we added max pooling. And then, yes, we can also add dropout because we have only 32 ones. So dropout is maybe I cannot drop out too much. So, well, I can add model add, well, drop out. Drop out how much? Drop out usually like a 25%, but too much here because small network, so like very small dropout. Okay, small dropout. And then here we do this one again. Okay, so we have this one, this layer, and this layer, and then of course we can add more, but to make it simple, I'll just flatten model add. Now flatten. Okay, now it becomes a usual neural network. Flatten. Okay, and then I will add usual dense network with again 32 neurons maybe. Modeled add, and then dense network, not convolutional network. Oh, yes, CU and CU and V. Okay. Okay, and then I add a dense network. Dense network, and then size is 32, and then activation function is ReLU, same ReLU function. Okay, done. Okay, and then here we can add the dropout again. Okay, model add like a dropout, like 1%, very small dropout. Okay, very small dropout, and then model add here the last layer. Now number of classes, num classes, and then activation function is now we have 10 categories, right? 10 categories from 0 to 9, 10 categories. And then for each image, I want to estimate the probability of, so for each image, this neural net, I will estimate probability of being in each category. So we have 10 category. So we have like a 10 probability, which have to sum to 1. Of course, if the model is correct, then the largest probability should be correspondent to the number, right? So here activation function to estimate the probability in categories in activation function should be softmax function. Activation is softmax. So softmax function estimate probabilities. Softmax function estimate probabilities for the categories. Okay, so let's run. So as always, we have errors. So activation num classes then actually softmax activation. What is the problem? And it got an unexpected dense okay, and then okay, it works. Okay, it works fine.